was Don Friedman's idea. He was the department head for land operations, and one of the projects that he thought would be appropriate for the land operations of the General Motors Defense Research Labs was the possibility of a commercial electric car. And so he asked me to start working on the concept of an electric car.
The Shopper car finds its roots in the development of the technology of the Lunar Roving Mobility Test Unit. Later in life, Don Friedman and his team would recognize that they pursued electric vehicle and lunar rover research simultaneously while employed by the Electric Drive Division at the General Motors Research/Defense Laboratories. The early months leading up to the pilot prototype Camaro's use are documented in a restricted General Motors file that chronicles the 1966 and 67 project activities of Paul Agrawal's Electric Drive Division. The report illuminates the struggles of the division after the preceding transfer from Santa Barbara. It also spells out a 10-horsepower battery-powered drive system for application in a small electric car using a high-speed DC motor. Using a solid-state controller for smooth speed and torque control, it required the design and fabrication of a hybrid prototype switch that would eliminate components for weight restriction. This report would go on to explain the technical aspects of the electric shopper car.
Another continuing stimulus to vehicle research is metropolitan traffic congestion. One approach taken is the development of special purpose vehicles. These vehicles might utilize electric power, small gasoline engines, or a combination of gas and electric power. Some special purpose vehicles under study are relatively low-speed performers that wouldn't mix in freeway or boulevard traffic. They would be handy for a run to the supermarket, school, or perhaps the golf club.
Utilizing a drive system with a total weight of 70 pounds, the hybrid prototype switch, and a remote battery source, it is slated for an operating testbed at the same time as the pilot prototype Camaro involvement. This is the exact mobility system that was created for the Lunar Rover Mobility Test Unit. The next time the shopper car was referred to was during 2 Senate committee hearings on March 16, 1967. Harry F. Barr, Vice President of General Motors Engineering Staff, assures these committees that General Motors is aggressively pursuing any method to energy conversion that offers potential for reducing automotive pollutants and better efficiency.
So they were very impressed, and they wanted to look at it more closely. They weren't eager to go into production with electric cars for reasons that I can quite understand. The logistics were not there for charging batteries. The batteries in those days were not like the ones that are available today. They were silver zinc batteries, very expensive, and not all that long-lived either. So that was GM's reaction to the Electrovaya. But of course, they did take credit with the public and with the government for having done this work.
The possible benefits and the unlikelihood that this vehicle would be accepted by the consumer was discussed in great detail. An opaque statement is made in a Dr. Howard Wilcox speech at a symposium in the following month, on the 6th through the 8th of April 1967, regarding electric vehicles. The gathering was entitled Power Systems for Electric Vehicles, and he was quoted with saying, "Air pollution problems have helped create a growing resurgence of interest in electric cars, but General Motors has other reasons for continuing their work in these areas." 1 year to the week later, Dr. Paul Agrawal, Richard W. Johnston, and General Motors released this research and technology to the public. The same technological advances that were created in the division's activity reports were recognized as having an application in lunar vehicles. The presentation outlined a system that would mirror the test beds for lunar activities, and an AC system that would ultimately find its way into the electrical advances of the Stirling electric hybrid. This was achieved with a simple addition of a frequency converter.
This test car, Stirlec 2, uses a diesel fuel burner as a heat source for an 8-horsepower Stirling engine. The engine drives an alternator to charge a bank of batteries which provide power to an electric motor that drives the car. The space required for this system, all the engine compartment and trunk space, added weight and high cost, make the design commercially impractical. However, it is a valuable test for continuing research and development.
The aforementioned DC system was used in the design, creation, and testing of the Lunar Rover Mobility Test Unit described in previous episodes.